Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to continue talking about my current project of coding the combat system for a viewer's game. In particular, I'd like to talk about a problem with the way that I've set up the enemies. You might remember that last video we set up the enemies in sets of 3 because the viewer whose combat system this is going to be wants a stacking limit of sort of 3 enemies per distance band. And so we'd set up enemy 1, 2, 3, then 4, 5, 6, then 7, 8, 9, 10, 11, 12, etc., for however many there are, getting closer and closer to the player character and any companions. This has a problem, which is that the code that does this sets it up one enemy type at a time. So it'll set up all the pupae, if there are any, then it'll set up all the males, I think, and then it'll set up all the females. It doesn't matter if that's the order. The point is that it sets up all the enemies of one type, and then all the enemies of the next type, and all the enemies of the next type. And that means that you get sort of all the males will be behind all the females. Like the females will always be up the front, the males will always be up the back, and the pupae will always be right up the back. So you could justify this in the fiction of the game, I suppose. You could say, well, that's the way that the insects socialize. The males, or that's the way they protect themselves. The males sort of circle the pupae to protect them, and then the females go on the fringes or something like that. But if you don't have a justification like that, you might want to mix up the enemies. You might want to not always have the males or the females up the front. You might want it to be random. And you might also want this just from the point of view of making more variety in the combat, so that you don't always get the same, or at least you don't usually get the same types first, and then you don't usually get all the males and then you get all the females, sort of thing. So what I've done is I have mixed them up. As you can see, they're still in groups of 3, but it's not enemy 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 1, 2, 9. Enemy 3 is all the way up here. Enemy 4 is up the front, then enemy 5, and so on, and enemy, up to enemy. How many are there? 1, 2, 3, 4, 6, 7, 9, 10, up to enemy 14, which is there. So that is done using a variation of a technique that we've already talked about a couple of times, called the Fisher-Yates shuffle. So I'm going to spend the rest of the video showing you the code that allows that to happen. So here we are in the code. I've zoomed in a little bit. As you can see, this new code is all in setup combat, and it doesn't require any new variables. It does require use of the variable stack, which we talked about in the previous video, but there aren't any variables which are new to this video. So here we have the page where we set up combat. I'm going to scroll down to the part where we are giving them the distance. This is all what we looked, everything sort of here and here. Oops, here and sort of here. All this is what we looked at last video. And immediately after that, we have some new code here. And there's a note here which says rearrange positions among enemies that have already placed. That should say have already been placed, or I guess I could have said that are already placed. But anyway, made a bit of a mistake. I'll fix that in the version that I upload to itch.io. So we have an if. Now W is the number of the enemy that we are adding. So if W is 5, we're adding the 5th enemy for this particular combat, and so on. And we say if W is greater than $stack, then do this. So why do we say, why have that if? Why not just do this for everyone? Well, we could do it for everyone, but it wouldn't make any difference for the first few enemies. Because think about it, if enemy 1, 2, and 3 are in the same range band, it doesn't, swapping their positions is not going to do anything because their positions are all the same. They're all in the same range band. It's only when we have enemies in more than one range band that swapping the positions of two enemies starts to make sense. And when does that happen? Well, that happens when we get over the stacking limit. So given that our stacking limit, which is stored in $STACK, $stack, given that our stacking limit is 3, which is set in initialize, it only becomes relevant once we get to enemy 4, because that's the first time that we have an enemy that has a different position to any other enemy. We could get rid of this, but it would just be, if we got rid of this, that if and the /if that is its partner, it would still execute. It would still do the same. It would do the same thing. It would just be, by doing that, we just save a little bit of pointless coding, and therefore a bit of pointless calculation. And as a result, we save a little bit of time, which probably doesn't make a lot of difference in this case because the combats are set up essentially as soon as you click, the page renders basically. There's not really an appreciable delay, but it is always good to be looking at these little ways to save time for when we might get to a project where it does matter. There is a delay and we do want to cut down that time. So here's what we do. Anyway, we set Z4 equal to a random number between 1 and W. So if we're dealing with placing the 5th enemy and therefore W is 5, we create a random number from 1 to 5. We store it in Z4 and we act if Z4 is less than W. So, and the act that we're going to take is to swap the positions, and that should say Z4, sorry about that, is we're going to swap the positions of enemy Z4 and enemy W. So let's say we're dealing with the 5th enemy, W is 5, we set Z4 equal to a random number from 1 to 5, and we say, is Z4 less than 5? Usually the answer will be yes. If we generated a 5 here, the answer will be no. But if we, let's say, generate a 3 for Z4, then we're going to swap the positions of enemy 3 and the current enemy 5. And the way we swap them, this is another thing that we've done several times. We do it in 3 operations using a temporary variable. We set the temporary variable equal to one of the values, in this case enemy W3, remembering that enemy, the array that deals with a lot of the attributes of the enemies, slot anything 3 is that enemy's position. So we set Z5 equal to this enemy's position, then we set that enemy's position equal to the other enemy's position, enemy Z43, and then we set the other enemy's position to the value we've saved in Z5, which is the old value of the first enemy. So if we follow that through, we will see that enemy W3 will have the value that enemy Z43 used to have, and enemy Z43 will have the value that enemy W3 used to have. It'll have Z5, and Z5 is equal to enemy W3, or enemy W3's original value. So we swap those two around, and having done that, we continue with the other attributes that we need, and then we continue through the loop. Then we look at enemy 6. We generate a value from 1 to 6, and if we get a 6, we don't do anything. We leave that enemy there. If we get, say, a 2, then we're going to swap enemy 2 and 6. And so an enemy might end up being swapped several times, but I'm pretty sure that this method will create a random arrangement, and it will have an equal chance of every possible random arrangement, with the exception that it won't rearrange enemies 1, 2, and 3 because of that if W is greater than stack requirement. Because there's no point. There's having enemy 1 swapping any of enemy 1, 2, or 3 with each other. Well, they've got the same. They're in the same position, so that swapping is not going to do anything. Of course, some of the swaps that you do subsequently might be swaps between 2 enemies that have the same position, but that's not predictable. What we could have done if we wanted to cut down on the amount of processing, we could have said if Z4 is under W, and we could have had if enemy Z43 does not equal enemy W3. In fact, if we did that, we wouldn't need that one there. So we'd only do this if the 2 positions are different. But that might cut down a bit of processing. Maybe that's slightly better. The way that I have it will have the same effect. Anyway, so the point is, at the end, we'll end up with randomly arranged enemies. We won't have a particular type of enemy always up the front, just because of the way that the algorithm places the enemies, which is what we had before. And that will be that'll make the combats slightly more varied. So that's how you do that. What I'm going to do next, because we've set up the enemies so there's 3 of them in each range band, but we haven't done anything to make sure that continues to be the case. So when they move, we need to code that they can't move if that's going to violate that rule. So that's what I'll be doing in the videos immediately to come. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.